Hello everyone, let's draw the Lewis structure of NO2, that is nitrogen dioxide. To draw the Lewis structure of NO2, we need to first calculate the total number of valence electrons that are available in NO2. Atomic number of nitrogen is 7, that means it has 7 electrons in total, therefore the electronic configuration is 1s2, 2s2, 2p3. This means we have 5 valence electrons and the 1s2 electrons are considered as core electrons. And then atomic number of oxygen is 8, therefore the electronic configuration is 1s2, 2s2, 2p4. Here we have 6 valence electrons. Together we have 5 plus 2 times 6 because we have 2 oxygen atoms. Therefore 5 plus 12 and that is equal to 17 valence electrons we have in NO2. Let's put the valence electrons around nitrogen and oxygen. Nitrogen is less electronegative compared to oxygen. Therefore, let's place the nitrogen atom at the center and then place the 5 valence electrons 1, 2, 3, 4, 5. And then we have 6 valence electrons for oxygen 1, 2, 3, 4, 5, 6 and then for other oxygen also 1, 2, 3, 4, 5, 6. The reason why we are not drawing the structure in a linear way here is because we have odd number of valence electrons. So, there will be a lone pair bond pair repulsion, half lone pair bond pair because we will be having a odd number of electron. In the case of CO2, we drew the Lewis structure in the linear fashion because there we have an even number of valence electrons and we do not have any odd electron on carbon, and that is the reason we drew the structure in a linear way there. But here that is not possible. So, let us make bonds now. Let us say we make 2 bond pairs with these 4 electrons and then 1 bond pair with these 2 electrons. So, if we do that, then the structure will be nitrogen, 1 bond here and then the oxygen is having 1, 2, 3, 4, 5 electrons here and then on the other side we have 2 bonds, 2 lone pairs and then we have 1 lone pair here. Did we account for all the 17 valence electrons here? Let us check that. We have 3 bond pairs that accounts for 6 electrons and then how many lone pairs we have? 1, 2, 3, 4, 5 and then we have 1 electron here. So, 5.5 lone pairs, that means 11 electrons plus 6 electrons from the bond pair and therefore total is 17 valence electrons. Now, this is not the best Lewis structure for NO2 because oxygen is in general more electronegative than nitrogen, and this means that we have to move 1 electron from the nitrogen atom to the oxygen atom, so that oxygen atoms will have 8 electrons around it and the nitrogen will have 1 electron on top of it. Let us check the octet configuration for each atom, and here this oxygen atom satisfies the octet configuration because we have 3 lone pairs and 1 bond pair, and the nitrogen atom does not satisfy the octet configuration. We have 3 bond pairs, only 1 electron, therefore 7 here, and then this oxygen atom satisfies the octet configuration, 2 bond pairs, 2 lone pairs, therefore 8 here. If we check the octet configuration for the other resonance structure, then we have 8 here, 2 bond pairs, 2 lone pairs, and then the nitrogen atom does satisfy the octet configuration here, and then this oxygen atom does not satisfy the octet configuration here. Now, why this resonance structure is preferred is because a structure in which negative formal charges that are placed on the most electronegative atom is preferred. Therefore, let us calculate the formal charge for each atom in both the resonance structures. We know that formal charge is equal to number of valence electrons in the atom minus number of lone pairs, that is non-bonded electrons, minus number of bond pairs divided by 2. Let us calculate the formal charge for the structure that is there on the right hand side. So, formal charge, and then for oxygen atom that is there on the left hand side, this one is equal to, we have 6 valence electrons in oxygen minus we have 3 lone pairs, therefore 6 electrons, minus we have 1 bond, therefore 2 by 2. 6 minus 6 is 0, minus 2 by 2, therefore that will be equal to minus 1. So, we have a minus 1 formal charge for this oxygen atom, and then the formal charge for nitrogen atom is equal to 5 minus, we have only 1 electron, half a lone pair, therefore only 1 electron, minus we have 3 bonds, therefore 6 by 2, and this will be equal to 4 minus 3, therefore that will be plus 1. So, we have a plus 1 formal charge for nitrogen, and then for oxygen atom that is there on the right hand side, this one is equal to 6 minus we have 2 lone pairs, therefore 4, minus we have 2 bonds, that means 4 by 2, therefore 6 minus 4 is 2, minus 4 by 2 is 2, therefore 2 minus 2 equal to 0. So, we have 0 formal charge for this oxygen atom. Therefore, the net charge for this resonance structure is 0. Let us calculate the formal charges for each atom for the structure that is there on the left hand side. So, formal charge for oxygen atom, this one that is there on the left hand side, is equal to, we have 6 valence electrons in oxygen minus we have 5 non-bonded electrons, therefore 5, minus we have only 1 bond between oxygen and nitrogen, therefore 2 by 2. So, 6 minus 5 1, minus 2 by 2 is 1, therefore this will be 0. So, the formal charge for this oxygen atom is 0, and then the formal charge for nitrogen is equal to, we have 5 valence electrons in nitrogen minus we have 1 lone pair, therefore 2 here, minus we have 3 bonds, therefore 6 by 2, therefore 3 minus 3 equal to 0, therefore the formal charge for this nitrogen atom 0, and then the formal charge for the oxygen atom that is there on the right hand side is equal to 6 minus we have 2 lone pairs, therefore 4, minus 2 bonds, 4 by 2, therefore this is 2 minus 2, that is equal to 0. Therefore, for this oxygen atom also the formal charge is 0. Now, even though we got all the formal charges as 0 for the structure that is there on the left hand side, we still prefer the structure that is there on the right hand side, is because a structure in which negative formal charges that are placed on the most electronegative atom is preferred. Here oxygen is the most electronegative atom compared to nitrogen, isn't it? And therefore, this resonance structure is preferred over the other one.